Good morning, everyone. My name is Seonhi. I'm Manufacturing Industry 4.0 Specialist at Ford R&A Europe. Today, I want to speak about the future of manufacturing, facilitating the evolution to Industry 5.0. I will start with the definition of Industry 4.0 and continue 5.0, and we will talk about automotive transformation phases. The main part of this presentation is product lifecycle management. I will show you the practical examples of Industry 4 and 5 technologies in the different product lifecycle. Finally, we will see how the factory of the future looks like after we applied all these technologies. At the end, Q&A session. Most of you are already aware what is Industry 4.0, but in order to get the same basis, I would like to go through quickly. So first industrial revolution is production facility and infrastructure revolution using water steam power. And the second industrial revolution is mass production with conveyor belt using electricity. Henry Ford was the main contributor of this second industrial revolution. And the third industrial revolution is automatization using electronic and IT system. And the fourth industrial revolution is cyber physical system using complete digitalization and net connection. Here, cyber means internet and physical system is things, so we're talking about also Internet of Things. Now the European Union is speaking about Industry 5.0. Until now, the industry is focusing on the economical growth and only shareholder values. But with the time, the people recognizing something is missing. We are humans. And we recognize also the planetary resource is limited and also all these climate changes. That is a background why European Union defined Industry 5.0. What is Industry 5.0? Industry 5.0 is not real industrial revolution, but it complements the existing Industry 4.0. We are focusing on three main areas. So that is sustainable, which leads actions and on sustainability and respect planetary boundaries. And second element is human-centric, that promotes talents and diversity and empowerment. And third, the resilience. It is agile and resilient with flexible and adaptable technologies. At the moment, the automotive industry is transformation phases to Ks. C stands for connected, A stands for autonomous, S stands for shared, and E stands for electric. In order to get the sustainable business, we need to have a robust product lifecycle management using Industry 4.0 technologies. Let's speak about the product lifecycle management. When we talking about the product lifecycle management, we are starting with design development phases and go through the procurement and production, and after vehicle is produced, it is transported to the customer and customer use it and the end of the life cycle, the vehicle vehicle parts are remanufactured or recycled. If we see this product life cycle, we have a lot of data. And when we connect those data and analyze it, we can have much robuster product life cycle management. We have different technologies in different phases we are using, and I will show you some of them in the product development and the procurement, production, transport phases, and also in the blockchain, AI, or wireless communication. Those are used for all product life cycle. Let's start with the new vehicle 360-degree sketching. We are traditionally, if you have the hand drawings to convert the 3D CAD model, it takes a lot of time. But with this tool, we can convert the hand drawings directly in the three-dimensional pictures, which you can see already the interior or exterior appearance. So the customer can give us very early phases of development their feedback. That is one of the human-centric design. And this tool is inspired by the video game Gravity Sketch. Next technology is generative design. Generative design is autonomous geometric design after specification and constraints. There are three categories. First, topology optimization. Second, biomimicry. Third, morphogenesis. Topology optimization is optimizing removing not loaded material from existing design. An example, here you have the existing design, and these parts are not loaded, so you can take out the materials iterative, so you can get this part which has much less material, means less weight. And biomimicry is the optimization after nature behavior. So you can see here trees or leaf structure or bone structure. And third method is morphogenesis, is optimizing design based on algorithm from the how group of cells respond to their environment. So cells actively loaded grow stronger. It is opposite method than subtractive topology optimization. It is additive method, and you can use the different softwares. This is giving us the sustainable aspect. But most of those designs is very difficult to produce with conventional production system. With the additive manufacturing, we can produce those parts. An example here, we have the conventional part, but we designed with the topology optimization with polymer material, and it is much lighter, and we don't need too long lead time. So the polymer additive manufacturing is state of application. We are doing some of metal additive manufacturing in progress, and also there is 4D printing is research. 4D printing is if you put some 3D printed material in some special environment, an example in the fluid, it can fold together, so it is assembling automatically. And at the moment, we are using the additive manufacturing mainly prototype or the tooling or low volume production. but we are working on to get the mass production. It is very much pending on production robustness, and also at the moment pre-processing and post-processing is very manual process, so still some of the work needs to be done to do the mass production. As we mentioned, the first examples, we are using virtual reality, augmented reality in the product development, in the product, but also we are using this technology for the production process, and also using for virtual training and also economic assessment. So with the digital model, we can do already the economic assessment. That's we can get very early phases, human-centered production process, and also because we do not change later, we have resilience. Next tool is the virtual commissioning. So with the virtual commissioning, we can put our equipment in 3D layout with a dynamic model into the production location, so we can assess early before we go into the physical commissioning. So it makes our physical commissioning much faster and easier with low risk. So that gives us also human-centered and the resilience aspect. We use also virtual reality, augmented reality in the workstation readiness, dynamic plant simulation, and also each station workload assessment. That is all basis for digital twin. The digital twin requires a complete granular and actual virtual representation first. So in the product life cycle, we have different digital twins. So we have product digital twin, production digital twin, and vehicle driving digital twin. And afterwards, you can have also recycling digital twin and so on. So in order to go through that, you need first product digital twins. So virtual product simulation and product testing, and that is verification required of those all virtual product and the testing, and the virtual production including those production simulation and also 3D layout, and then you have also verification of virtual product and virtual production, and the virtual commissioning is included, and virtual workstation process check. If you have all those virtual models and then you put your production line, and then you need also real-time data, all those production lines and also connected. So that is need to verify with the virtual model and the real-time production. If you can have it both of the virtual model and verified virtual model with the real-time data, in that point we can talk about digital twin. We still need to have some work to do, and I think this digital twin, if you have it, that will give us big advantage. We can do any changes evaluation first digitally before we do physical changes. So that gives us human-centered, resilient, and sustainable as all aspects. Next technology is collaborated robot. It is example column assembly plant. The operator is working with the cobots together to installing shock absorber into the car. Next example is the auto-guided vehicle in the Valencia body shop.
The main duty for the road is to deliver the spare parts to all the station in the line, in this case in body and stamping. This autonomous road doesn't need any external guide to navigate. We call him survivor because the intention was to avoid hazards.
Next example is in the Dagenham engine plant. We are using drones.
Potentially dangerous but essential tasks absolutely risk-free. A group of Ford workers are flying drones around their factory to do just this. To carry out vital safety inspections of high-up or hard-to-reach places, Dagenham engine plant workers are using drones with cameras to safely and efficiently inspect machinery and roof areas.
We wanted to take the risk of these inspections away from the employee. By using a drone, we can do that.
Previously, staff had to climb scaffolds to check 40-meter-long overhead gantries. Now, maintenance staff can zoom in on each area with feet firmly on the ground. The whole production facility can be covered in a day by controlling drones equipped with GoPro cameras to thoroughly inspect each area, ensuring they're well maintained and comply to rigorous safety standards.
Fluffy, come here.
Next example is
Time for
Fluffy.
day at work. Fluffy, come here. Good dog.
I'm Mark Goddard in the Advanced Manufacturing Center here at Ford Motor Company. I'm the Digital Engineering Manager, and I'd like to introduce Fluffy, our quadruped robotic dog. So this is a Boston Dynamics Spot. We've nicknamed him Fluffy, and we're utilizing it to actually do laser scans of our facility. That image is then utilized by our engineers to develop new vehicle programs, and it allows them to develop more accurate layout of our facilities. These cutting-edge technologies allow Ford Motor Company engineers to save money, retool facilities faster, and bring new vehicles to market sooner.
Hi, my name is Paula Weebelhaus. I'm Fluffy's handler. Considering I've never had a game controller in my hand before I received Fluffy, at first I'm not going to lie, it was kind of intimidating to be in control of a dog that is this high tech, but he is easy to operate and he maneuvers well through spaces. He'll go into some tight areas that Scout, our other robot, won't be able to accommodate. I have never owned a dog before in my whole entire life, so this is our first entry into dog ownership. Like people bond with their cars or with certain tools in their workshop, I certainly have bonded with my companion dog, Fluffy.
Fluffy definitely has a coolness factor. So it's been amazing to be able to take something like Fluffy and turn it into a usable engineering tool for our company. The opportunity here and what this robot dog can do is significantly going to change the engineering community. It also gets people excited about the fact that we're on cutting-edge technology here at Ford Motor Company.
Next technology is blockchain. It is used in the Bitcoin at the beginning. It's all participants in the value chain approve their ledgers. It's like a digital fingerprint, and it's clear and safe documentation. But there still needs a lot of computer capacity. At the moment, we are working with IBM how we can do it with the combination AI and blockchain technology. It is ideal for the supplier chain management from raw material to the end of cycle to do product life cycle tracking. It is reflecting resilience and sustainability. Next example is 5G application in.
We
we've got a long
UK.
history of manufacturing
Ford
vehicles
UK.
with internal combustion engine technology, but we're in a process of total transformation. For us in Ford Motor Company in Europe, we are ready to deliver that significant pace of change in terms of the adoption of plug-in and fully electric vehicles.
We have to very rapidly redeploy all the assets that we've got into factories that can meet low carbon vehicles by 2030. The factory of the future is all about moving data, and 5G is an enabler for that. Ford has a long-standing partnership with Vodafone. Building a pilot line with 5G was a great opportunity for us to then look at the technology, understand the technology, and without this learning, we wouldn't be able to consider doing this in one of our plants.
One of the use cases here in Dunton, using the Vodafone mobile private network, is on our welding machines. So we're capturing images before we're welding and then after we're welding, and then we can use AI and feed back to the machines if the weld isn't particularly good, and then change and re-weld whilst the part is still in the machine. You could be welding and creating terabytes of data very, very quickly. So it's important that we have the connectivity that can keep up with that and that can send that data and store it as quick as we're producing it.
We've been able to see data back from the laser process that tells us that we're getting a build-up of heat in our lenses, which means that we need to replace them. We could then contact an expert to discuss it, but we can also use the 5G network in conjunction with a HoloLens system to guide an operator through the process of changing that lens. We're keen to make sure that we can connect securely, and of course with 5G you have the ability to use SIMs on every single device and make sure that you're aware of every device that's communicating on your private network.
We've got plans to totally transform our vehicle lineup over the next 10 to 15 years. The manufacturing engineering team are at the centre of the change of EV powertrain in Europe, and this team needs to work with people like Vodafone so we can do that as efficiently as possible.
Summarize the factory of the future, how it looks like after we applied all those technologies. It looks like integrated planning and execution with real-time track and trace. When the customer ordered the vehicle, that is connected to production plan, supplier chain management, logistics and production plant, and also distribution, and also when the customer will receive the vehicle. And in the logistics, it will be self-monitoring and self-adaptive logistics. And also intra-logistics, we will have smart shelves and also autonomous remote driving within the plant and the logistics when the vehicle is completed. And the facilitating inventory monitoring and also automatized reordering will be part of them. Of course, the wireless communication will be also part of them. In the production, AI optimized, built, flexible and integrated production plan and execution. And also predictive maintenance and predictive quality is closer to the zero failure and high efficiency through the real-time monitoring and controlling. And digital twin will be part of them with the Internet of Things in the real-time data and cloud connected and edge computings. And also integrated AI and human interaction. The robust product lifecycle management with blockchain and AI to enable the sustainable business. So factory of the future will reflect all the aspects, human-centered, resilient, and sustainable factors. Thank you very much.